the most promising thing to say has thought to be the principle of indifference. So the idea is that if you have several different options and you have no more reason to think that one will obtain than you have to think that the others will obtain, then you should assign them all the same probability. Okay, if you have some options and you have no more reason to think that one will obtain than you have to think that the others will obtain, then you should assign them all the same subjective probability. So this principle seems eminently sensible, and yet I claim that, thus stated, it is inconsistent. I was horrified when I first read about the example that I'm going to tell you guys about. I'm going to describe an example, and I'm going to claim that the example shows that that cannot be right without modification. So suppose that you have a factory that makes cubes. And you know that every cube made by the factory has a side length of less than or exactly 1 meter. So side length is equal to 1 meter or less. But you have no more reason to think that the actual value of the next, of the side length of the next cube is going to be one value in this range than you have that it's going to be any other. And now suppose someone asks the question, what is the probability that the side length will be in that range? So in other words, that the cube will be at least half a meter in side length. So here's a way in which you can answer this question by using the principle of indifference. So you say, well, we have two options. Option one is that the side length is going to be in here. Option two is that the side length is going to be in there. And really, we have no better reason to think that it's going to be one rather than the other. It's true that there's a point that's there and not there, but you know, points should get probability 0, presumably. So because you have no better reason to go for O1 than you have to go for O2, then surely the answer goes, the probability should be 1/2. What we did here was talk about different values that the side length might take. But of course, we could have reasoned in a different way. We could have said, well, I want to think not about the values of the side length, but the values of the volume. And one can say, look, we know that the volume, so if the side length is anywhere between 0 and 1, the volume is going to be in that exact same range. So we have two options. Either it's in the 1/2 1 range, or it's in the 0 to 1/2 range. And again, we have no more reason to think that this obtains than we have that that obtains. And then, of course, we're going to get very different results, because that suggests that the probability that the volume is in this range is 1/2. But of course, the cubes that have a volume of 1/2 are not the cubes that have a side length of 1/2. They're the cubes that have a side length of 1/2 to the 1/3, which is about 0.8. So that means that we get a very different result. So without some kind of further constraint, the principle of indifference leads to inconsistency, because applied one way, it tells us that the probability of a side length in this range is 1/2. Applied another way, it tells us that the probability of a side length in this range is different from 1/2, because the probability that the volume is going to be over 1/2 is 1/2, and therefore the probability that the side length is going to be over 1/8 is 1/2. So question for you guys. What shall we do? Is there a way of fixing the principle of indifference?
I think the problem is that we have two things we can be indifferent about, the volume or the side length. And if you choose like a probability distribution over the side length with just like, just like constant everywhere, then you get a different probability distribution over the volume. And if you choose the volume to be the straight thing, then you get a different, so you just choose which one is going to be, I don't know how you choose, but the problem is that we have to choose which one we're going to be indifferent about, side length or volume.
That's exactly right. So here's a way of generalizing your point. So application of the principle of indifference presupposes that we have a set of categories that are the ones that we're going to use to decide what to be indifferent about. And what you pointed out is that one way of choosing those categories is by, say, volume is a category. Another way of choosing the categories is by saying side length is a category, and we just have to make up our minds. So I think that's right so far. But then, of course, that means that we're left with the problem of how to choose the right categories. And the problem with this case is that it's not obvious that somehow volume is special or side length is special. This, to my mind, is the greatest disappointment in the theory of probability. There are other big disappointments, and next week we're going to see another pretty big one. But this, I think, really cripples the theory. It means that there are just limits to what we can do. There was an all-out effort to try to overcome this problem by someone called Rudolf Carnap in the 20th century. And, heroic efforts were made, and, a bunch of interesting math was developed. But at the end of the day, we do not have an answer to the question, how do you decide what categories to use? OK. So much for the principle of indifference.